Hello students, good time to all. I am Chandan Pradhan. Welcome to your YouTube channel Chandan Physics. In this video lecture, we are going to discuss functions of more than one variables. Let's start. The name indicates functions of more than one variable, means it has 2, 3 like this, the variables rather than one. The question arises, for what reason we introduce the functions of more than one variables, or what are the physical significance, what are the physical meaning, and for what reason it is introduced. Let's we discuss it one by one. We are quite familiar with quantities which depend on two or more variables. So examples, the area of the triangle, we know it as half height into base. That's why the area of the triangle depends upon two variables. One is height and another one is base. Again, if we take examples like the area of a rectangle, the area of a rectangle, that is the product of length into breadth. Length into breadth. That's why the area of rectangle also depends upon two quantities, one is length and another one is breadth. Again, if we take the area of an ellipse, that is depends upon, the area of an ellipse depends upon what? That is its semi-major axis. Semi-major axis small a and semi-minor axis small b. This is an ellipse, semi-major axis small a, semi-minor axis small b. And if we consider in three-dimensional cases, the volume of a parallelepiped, the volume of a parallelepiped, figure looks like this. These sides are parallel and that sides also parallel, and that's why that figure is known as our parallelepiped, and the volume of that parallelepiped depends upon its length, breadth and also height. Length, breadth and height. These are the examples. Look it in a very careful manner. The area of a triangle depends upon two quantities, one is height and another one is its base, and similar way area of rectangle, length and its breadth, and ellipse, that is semi-major axis small a and semi-minor axis small b, and the volume of parallelepiped, length, breadth and height. These cases, in that three cases, the dependence quantity is 2, and that particular case, that is parallelepiped, the volume of that parallelepiped depends upon its three quantities. So how we can mathematically design or mathematically determine these variables in a significant way, so you introduce the functions that is more than one variable. But in the previous section we are studied about let the function y is equal to f of x. In that of case that is a single variable, that is x, but what is its demerits that creates a new way to study, that is functions of more than one variable. So we can mathematically easily write z is called the function, z is called the function of two variables x and y. If z has a unique value, or we can tell it as a definite value for every pair of value of x and y, it can be denoted as, we can write it as z is a function of x and y. Z is a function of two variables. Variables are, one is x and another one is y, and it can be denoted as z is a function of f of xy. Here x and y are called independent variables. At that case x and y is called independent variables. And z is called the dependent variable. Dependent variable. Again, when we are studied in a one variable function y is equal to fx, whereas x is the independent variable and y is the dependent variable, and also we are taking as what's the domain and range of that of a particular function. So what are the basics are in the one variable function, also more than one variable function we are taking as, that is two variable function, that is z is equal to f of xy, whereas xy is independent variable and z is dependent variable. We can also taking as what are the range and domains of that of a two variable function z is equal to f of xy. We can write it as the set of points, xy, points are like this xy, in xy plane, for which f of xy, that is the function for which f of xy is defined, is called the domain of the function. That is the domain of the function. What is the domain? That tells the set of point xy. The points are in the form like x and y in xy plane, that is the coordinated plane like this. We can tell it as xy plane. All the points are in xy plane are designated as x comma y. These are the points which are under xy plane. So the set of points xy in xy plane for which f of xy, the function is look like this, that is f of xy is defined. The condition is that f of xy is defined. The term is defined, is called the domain of the function. These are the set of points xy in xy plane for which f of xy is defined, is called the domain of that of a function. Again I repeat, the set of point xy in xy plane for which f of xy is defined is called the domain of the function. Also we can define what is the range. Range we can write it as, what should be the range of that of a given function z is equal to f of xy. The function is z is equal to f of xy, that is a two variable function, that is more than one variable. So in that of case we define in the domain, again we define what is that of range of that function. We can write the set of corresponding values of Z is called the range of the function. The function is given as Z is equal to f of xy, a two variable function, whereas xy is the independent variable and z is the dependent variable. So in that of a function we can define what should be the domain and what should be the range. So we define what is the domain, that tells the set of point xy in xy plane for which f of xy is defined is called the domain of the function. This is called the domain of the function. And the set of corresponding values of x, the corresponding values of z is called the range of the function. The values of z, that for the xy, that for the domain is known as the range of that function. So further we proceed, what is the limit and what is the continuity of a two variable functions or the functions of more than one variable. What should be the definition of limits and what is the continuity. We can proceed as further. We write it as or define what is the limit concept in case of two variable or the functions more than one variable. We define limit it as if z is equal to f of xy, two variable function, be a function of two variable then it is set to have a limit small l. Have a limit small l, that is the limiting value of that function z is equal to f of xy. Condition is l is as x tends to a or x approaches to a and also y tends to b, if and only if, the condition is if and only if, what is that condition? It tells the limit small l is independent of the path when x tends to a and y tends to b. It is denoted as limit x comma y tends to a comma b. The function is f of xy is equal to small l. Also it can be further written as limit x comma y tends to a comma b, that also leads as x tends to a or x approaches to a and also y approaches to b or y tends to b, that is written as x tends to a, y tends to b, function f of xy tends to small l. This is the writing way of the limit of the functions of more than one variable. The functions of more than one variable. The function was given by z is equal to f of xy is the function of two variable. Its limit is said to be small l, its limit, whereas x tends to a and y tends to b. That means when x approaches to a and y approaches to b, at that particular condition the function f of xy approaches to a value that is small l. Condition is taken as if and only if limit small is independent of the path when x tends to a and y tends to b. Independent for that of condition for the path. So in a writing way we can written it as limit xy tends to a b, f of xy is equal to small l. In the further manner or in delta notation, we can define a limit concept in terms of delta. In terms of delta neighborhood of AB, there exists a given real number that is epsilon greater than 0. Epsilon is positive, that is greater than 0, however small. Epsilon is too small. We have a real number. We have a real number. What is that real number? That real number delta also greater than 0. That real number delta is also greater than 0, such that the writing scenario is the function f of xy minus small l, that is the limiting value, modulus less than epsilon for x minus a modulus less than delta and y minus b modulus less than delta. So limit in terms of delta neighborhood, we can define the limit in terms of delta neighborhood of a comma b. There exists a given real number epsilon greater than 0, however small. Epsilon is too small. We have a real number. When epsilon is too small and delta is the neighborhood of a comma b, then the real number delta is greater than 0, such that the condition is what? The function f of xy minus l, that is the limiting value, the modulus, the difference of the modulus f of xy and l is less than epsilon. For x minus a modulus is less than delta, and the difference, the modulus of the difference y minus b is also less than delta. Then the real finite number small l, that is the limiting value, that is the real and finite number small l is called the limit of the function. The limit of the function f of xy, the two variable function f of xy as x comma y tends to a comma b, that indicates x tends to a and y tends to b. The limit of z, the limit of z is equal to f of xy exists only when the same value is obtained for the limit along any path in xy plane as x tends to a and y tends to b, or along y tends to b comma x tends to a, that is in the alternate way, x tends to a or y tends to b, or we can written as y tends to b and x tends to a. This is the another way to define the limits in a two variable functions in terms of delta neighborhood. That is the total definition. In terms of delta neighborhood, we can define the concept of limit. So there are so many results in terms of limit. We can now discuss some results in the limits of two variables, or we can tell it as some theorems or basic principles. If limit x tends to a, y tends to b, f of xy is equal to small l, and limit x tends to a, y tends to b, another function g of xy is equal to m, then we can write the addition of that two results. Limit x tends to a, y tends to b, f plus minus g results l plus minus m. When these two are multiplied, this is addition and subtraction. Also for multiplication, limit x tends to a, y tends to b, f into g, the limiting values are also multiplied, that is l into m. Again for division, limit x tends to a, y tends to b, f divided by g, the result is l divided by m. Our given is f of xy is equal to small l, and g of xy, the limiting value when x approaches to a and y approaches to b, that function g of xy approaches to m. Again addition, results are addition. Multiplication, also the results are multiplied. Division, also these limiting results are divided. So in this way we define the limits and some basics of limit: addition, subtraction, multiplication and division. And again we define the concept of continuity for functions more than one variables. So let's start continuity. Continuity, how we define the concepts like continuity in the functions of more than one variable. We can write it as the function f of xy, that is two variable function, is said to be continuous at a point is given as a comma b if limit x tends to a, y tends to b, f of xy is equal to f of ab. A function is said to be continuous. A function is said to be continuous in a domain if it is continuous at every point of domain. At every point of the domain but if the function is not continuous, it indicates continuous at a point, then it is said to be discontinuous at that point. Discontinuous at that given point. The point at which the function is continuous, then at that particular point also that function is discontinuous. So we can define continuity it as like this: the function f of xy is said to be continuous at a given point. The point is given as a comma b. Condition is the limit x tends to a and y tends to b, f of xy is f of ab. That means when x approaches to a and y approaches to b, that function approaches to f of ab. A function is said to be continuous in a domain if it is continuous at every point of that domain. The function is continuous in the domain when it is continuous at every point of the domain. There will be no such points at which the function is discontinuous. Each and every point of that given domain is that a function is continuous. But if the function is not continuous, indicates that that function is also discontinuous that given point. That point, a given point is that and the question tells prove that that function is continuous or discontinuous at that given point. The domain in which the functions is continuous at all points, that indicates that that function is also discontinuous on that given points. So there are some examples related to our continuity and limit concept for the given section, that is functions of more than one variables. So let us take some examples, or we can solve some questions that are related to our discussions. So the question is, find the value of limit x y tends to 0 0. The function is given by xy divided by y square minus x square. So the question is given as like this: find the value of limiting for that. So how we can take the solution? We evaluate the limit at x tends to 0 and also y tends to 0, and also along the line, that is y is equal to mx plus c. If these three results are same, then we told that limit is exist. If not, then that limit is not exist, so we cannot define or cannot evaluate the limit of that given function. So we can write limit x tends to 0, y tends to 0, xy divided by y square minus x square is equal to limit y tends to 0. When x tends to 0, we can evaluate at x tends to 0, and 0 is equal to 0. Again we can evaluate at y tends to 0, then we can write it as limit x tends to 0, y tends to 0, xy divided by y square minus x square is equal to limit 0. When x tends to 0, result is 0. These are the two cases. One we evaluate the limit at x tends to 0 and another y tends to 0. Again we can evaluate it along the line. That is y is equal to mx plus, that is y equal to mx, and along the line c is equal to 0. We get limit x tends to 0. That means y is equal to mx. We put the conditions of that of limit x into mx. In place of y we write as mx square minus x square. That value is limit x tends to 0, that is mx square divided by x square whole into m square minus 1. Evaluate the limit at x tends to 0. The limit is m divided by m square minus 1. Look at these three conditions. At x tends to 0, evaluate it as 0. Again y tends to 0, 0, and along the line, that is m divided by m square minus 1. In that of three cases, these are not different, so we can write, or we cannot find the limit of that of given question. So which is different value of m? So the limit does not exist. This is a problem related to our limiting concept of functions more than one variable. So again, a question for that of continuity concept. What is that a question? The question is given as test the continuity at the function at origin is given by, the function is given by f of xy is equal to x square minus y square divided by square root of x square plus y square for x not equal to 0 and y not equal to 0. Again that value is 0, condition for x equal to 0 and that of y equal to 0, that is at origin. So we can check the continuity, we can define the continuity. So by using the definition of continuity for functions more than one variables, we can find out the solution, or we can test the continuity of that of given function. So first of all we calculate the limit at x tends to 0 and then x tends to, that is y tends to 0, and finally along the line. So then we can say either that function is continuity or not, that of given point, that is at origin, and that is x tends to, x is equal to 0 or y equal to 0 condition. Limit x tends to 0, y tends to 0, f of xy is equal to limit x tends to 0, y tends to 0, x square minus y square divided by x square plus y square, square root of this function is equal to limit y tends to 0 minus y square divided by y is equal to 0. Evaluate at x tends to 0. Again at y tends to 0 evaluation, x tends to 0, y tends to 0, f of xy is equal to limit x tends to 0, y tends to 0, the given function x square minus y square, x square plus y square square root is equal to limit x tends to 0, x square by x is equal to 0. Again along the line along the line is equal to y equal to mx, that is the equation of line. We have limit y equal to mx and x tends to 0. The function is f of xy. Limit y equal to mx and x tends to 0, x square minus y square divided by x square plus y square square root is equal to limit x tends to 0, put y equal to mx, so x square minus m square x square divided by x square plus m square x square square root is equal to limit x tends to 0, x square common 1 minus m square, we common it as x square, so square root of x square is x, 1 plus m square square root. So evaluate the limit at x tends to 0 is 0. So in that of 3 cases the result is 0, 0, 0. So we can write it as, hence the limit along any path is same and exists having a common value. That is, the common value is limit x tends to 0, y tends to 0, x square minus y square divided by x square minus y square square root is equal to 0, which is equal to f 0 0, as f 0 0 is 0, that is at origin. Hence the given function is continuous. Hence function is continuous at origin. So we can prove, or the question is that test the continuity. So we check the continuity test, and that is continuous at origin. So we can test it. So in the entire video lecture we are discuss about the functions of more than one variables. We define how these functions are depends upon 2 or 3 variables. Then we mathematically denote it as a function, how f of z is a function of f of xy, and what is xy and z, and again define domain, range and limiting concept, and also the limit definition of limit in terms of delta neighborhood, that is delta neighborhood section, some results related to our limiting concept of more than one variable, and also the continuity, define the continuity. And there will be 2 problems, one problem based upon the limit and another problem is based upon the continuity. This is all the discussions regarding the entire topic. So with this valuable notes, let me wind up this session. Thank you.